Hello and welcome to this tutorial for magnetic particles for the Unity Asset Store. Today I'm just going to show you quickly how to create a really basic lightning effect like you see here. So let's just dive straight in. To start with, you do need the magnetic particles tool. That just provides you with a script to influence the Shuriken particle system by providing a reference transform, telling the system what kind of magnet that transform is. So in this case it's an attracting magnet. It could be a repulsing magnet if you want it to be. What kind of magnetic modification is being applied. So in this case we're using a directional noise modifier, which means that it's attracted to the transform's location but with some noise applied along that path. It could just be positional modifier, which would mean that it moves in a linear fashion straight to that path. A direction, which means it approximates the direction that particle, that transform is in from the particle, and will move randomly along that direction. Or you could have a bounded position and bounded direction, which means we set a range for which this magnetic effect can happen within. But in this case, we're just using directional noise. And then there's a second magnet here. And you can see here, our magnet system size is 2, so it's the first one. I've run through that. The second one is also an attracting magnet. Instead of using directional noise, it's using positional noise, so that with the two noise types and the two transform locations, which you can see here, zoom out a little bit, by providing two transforms, we're getting a bit of fighting happening, which is increasing the frequency of the noise we have. And by using a directional and a positional noise, we're also introducing some more fighting there for a more varied kind of lightning bolt looking effect. The scale simply refers to how powerful is the effect of this magnetic influence, and then the distance in this case tells us kind of where this is taking place. So if we increase that distance, you won't see much of an effect, but the positional noise magnet will then affect the whole thing. What we want it to do is affect kind of the last stages, so we get a bit of a positional influence going on towards the end of the lightning bolts last time, if it makes it down here, just for a more kind of accurate effect. Cool, we can turn that visualizer off. So I'm just going to show you how to set that up from scratch. We can just turn this cloud off, we don't need that. So what you need to start with is a particle system, and we'll just start with the default one. We'll zoom in a little bit. We'll crack the particle system open to start with. We'll shorten the lifetime. A lightning bolt doesn't need to be around for that long. Start lifetime to 1, start speed to 1, and the max particles is the other one we want to look at. If you want just one lightning bolt, just set that to 1. If you want any more, you could set that to 2 or 3 or 4 or however many you want. We'll start with 1 just to see what we get. Emission wise, rate over time, I prefer to use a burst for this one. You can use a rate over time setting, that's fine, but in this case we'll just go with burst, cycles to 1, interval at the lowest it can go. And then we'll go to shape. We're using a cone right now. I think we'll just keep using a cone, that's fine. But I might quickly jump in and shrink it a little bit just so it's more targeted. And let's have a look. I'm just going to get rid of that gizmo for a second because it was in my way. Alright. Cool, so that just means we'll get a bit more of a targeted emission, and I'm going to switch that around 180 to face down, more like lightning would, and we should be good to then go and turn on the trail renderer. That's an important part of this system. It's the only part really that we're going to use, because we will go ahead and turn off the billboard rendering entirely, because all we want is the trail. And we need to apply a trail material, so I'm just going to use the default sprite just for the sake of this demonstration. Cool, so now we've applied all those settings using the particle system. What we need to do is attach this particle magnet script, and we'll start with 1, and I'll run you through how that works. So we have one magnet container ready to accept a magnet transform. Just create an empty transform, that's fine. Call this magnet_1. Just change the particle system name to lightning. Ning. Cool. And then we'll drag this reference transform for the magnet into this magnet transform box, and we'll then have a look at where that is in the scene in relation to the lightning. Okay, it's right on the same spot, so we want to move that down a bit, otherwise it won't kind of render correctly. So currently the scale of the magnetic effect is 0, so we'll change that to, let's say, 80, and we're going to need to turn the magnetic effect on. And currently, because we have it set to repulse rather than attract, it's actually trying to push away the particle from the magnet transform position. So let's just change that to attract. And then what you'll see is it now, when it emits, shoots directly towards the position of that transform. What we don't want is it to be doing that. We actually want to tell it to move in the general direction of this transform, and we want to do that with some noise applied to the path of the particle, just so we get a bit of a jaggedy effect. In this case, because the emission of the particle system is telling it to move on its own, we're not actually getting a lot of directional noise. So what I found is a good thing to do here is add a second particle, a second magnet, to affect the system. We can just duplicate that magnet transform, change it to magnet 2, and we can move that to a different location so that when we have the 2 going, and we'll need to drag that magnet transform in here to update this. With 2 magnets going, we'll be able to get some more, basically we'll get some more fighting between the 2 noise components, and that will cause it to look a bit more like lightning. So right now that's not working. We're going to turn on visualize and increase the distance of the effect for this one here. Let's see, let's change this to positional noise. So the lightning bolt tries to move directly to the location of this transform, and within the sphere is the area that will be affected by this magnetic effect, essentially. If we change the distance down, it'll still be affected by it, but not as much. And if we scale that all the way down to nothing, you can see that it no longer does anything. So by increasing the effect, we'll just get some more fighting with the 2 positional the 2 noise components. So let's just set that to 5. Cool, that should be good. And we'll just turn off the visualization of this distance or the magnetic kind of bounding area, magnetic effect bounding area. Cool, so it doesn't quite look like lightning yet. I think that's just because it's not kind of tapering off at the end of the bolt. We can easily fix that. So if we just go into the trail component of the particle system, we can say width over trail. We'll change that to a curve, and we'll just go into the curves editor, and we'll say drop the end of the lifetime down to 0. I might just add another key there because it's not quite looking how I want. And we'll pop that up here so kind of scales down right at the end rather than gently along the whole trail. There you go. So sharpening off to a point, and I think we can probably fade it out, leave a bit of a color over lifetime by applying a gradient there as well. So we'll add another alpha key and we'll drop that one down to 0. Let's see, and now it fades out nicely at the end of its lifetime, and that should prevent any artifacting or any jaggy bits that we don't want to see at the end of the lifetime. Cool, and then you might want to change the color. You can do all that using the standard particle system stuff, but just for the sake of showing you right now, let's go into color over lifetime. We'll turn that on, change that to gradient. It was already set to gradient, but never mind. And let's say I'm going to create another key there just to make sure it stays white until it's kind of fully spawn, and then I think we should go and change it to yellow, make it look a bit more like lightning. Oops. Yellow, maybe a little more orangey. There we are. Cool. So starts white, bit of a flash, and then finishes off yellow as it cools down. Just like a, not quite just like a normal lightning bolt. I think they kind of go blue and purpley and all these different colors, but you could do that yourself. And then just to quickly show you how that we could add another bolt to that. Let's just change the max particles to 2, and it should give us 2 bolts. There you go. They're kind of overlapping right now. Let's say go to 4. There you go. Get a couple of bolts coming at once. And you see this fighting down at the end here. That's just a result of having the lifetime kind of too long. So the particle's not actually, well, the trail's not actually getting a chance to fade out before it gets captured by that magnet. So let's just change that back to 1, and it won't happen as much because there's less particles to be kind of caught up. But yeah, so basically that's how you kind of can create a lightning effect using this tool. It's very straightforward, kind of much more straightforward than it would be were you using just a standard particle system. You can take this as far as you want, but for the sake of this example, I think that's kind of enough, and you can go ahead and make it look all special on your own. Cool, so thanks for checking it out, and keep tuned, and we'll put up a few more tutorials for practical uses for this tool, and yeah, I hope you like it. Thank you.